So while it's extremely important to look at the global implications and the global reach of electrochemistry, it's also remarkable to see how unifying the ideas intrinsic to electrochemistry are to other areas of chemistry. And a perfect way to demonstrate this is to look at the first 6 chapters, which we've covered up to this point, and see how electrochemistry brings all of the ideas, or many of the ideas, in all 6 of those chapters into one unified representation. So let's start out and point out that in Chapter 1, we looked at energy and energy conservation. In Chapter 2, we looked at oxidation-reduction reactions. In Chapter 3, we looked at the first law of thermodynamics. In Chapter 4, we looked at entropy and the second law of thermodynamics. Then we turned to the equilibria chemistry that is driven by our understanding of Gibbs free energy. Then we moved on to acid-base reactions. And we'll go fairly quickly through an analysis of how electrochemistry unifies all 6 of these areas of chemistry. So let's start with Chapter 1, and that carries us back to the idea of what energy is from a scientific point of view. And as we pointed out, from Aristotle, for the next 2,000 years, the concept of energy in a scientific sense was ill-defined. And we can also mark the advent of modern advances in science to the point where we finally understood what energy is, and the fact in particular that it's conserved. That is, nature can convert energy from different categories, but always conserves the total amount of energy in that transformation. And it was Joule who did experiments in which he took a mass, placed it in a gravitational field, and related the change in height, which was the release of potential energy, and converted that to heat by a paddle system in this simple apparatus. And what that did was it converted macroscopic energy to microscopic energy. But more than that, it provided a profoundly simple way to measure energy of all different types. And of course, potential energy is mechanical energy. So it allowed Joule to equate the energy release from the descent of those masses in a gravitational field, which we can write as mg delta H, and relate that directly through mechanical energy to the heat delivered to that system, which he could measure simply by looking at the change in temperature. And he measured that change in temperature with a thermometer, and the heat capacity of the metal, the water, and so on in that system was a constant, and thereby he could establish an absolute energy scale. And in fact, 1 joule, and it's named after him because not only did he demonstrate the equivalence of mechanical and heat energy, but in so doing he established an absolute scale for energy, and 1 joule is equal to 1 kilogram meter squared per second squared. Now that's remarkable, the mechanical equivalent of heat. But what's more remarkable is that any other source of energy can be put on the same absolute scale. That is, you could take the sun, pass it through a window at the top of his laboratory, and reflect it into the base of that same apparatus. So the heat capacity of that apparatus was the same as it was when he was putting mechanical energy into it, but this time he's measuring the flow of photons, the number of photons times the energy per photon, and calibrating that exactly against mechanical energy. So he can take electromagnetic energy, light, and measure on an absolute scale in the same way he did mechanical energy. But the plot gets even more interesting because he can pass electrons through a filament, which is very similar to a heater that's driven by electricity or a light bulb, and the flow of electrons through that filament provides heat that can be directed into the same apparatus, and we can calculate the energy release from electricity with the same system. That is the electrical equivalent of heat. And finally, we can measure the chemical release from the combustion of methane, for example, so we can relate chemical energy to exactly the same scale by placing a Bunsen burner under the same apparatus and feeding natural gas or methane into that Bunsen burner.